So I'd like to introduce our next speaker. Those who've been with Allotrope Foundation for a while have seen this sort of like ongoing periodical that we do from Merck about our journey towards trying to scale ASM, and today is the next series in it. Our speaker is Chris Siegler, who is now leading our internal implementation effort, and he'll tell you the latest in where we are, not only scaling up the implementation of ASM, but everything from the capture to the consumption of data. And actually, it's moved far enough along, he can actually show you some working demos. So.
All right, thank you. All right, so I know we're in this really great view. For all of you that are online, I'm sorry you don't have this great harbor view. But for the next 30 minutes, I'd like us to leave that all behind, right? I promise I'll bring you back, right? So you don't have to leave this view forever. But for the next 30 minutes, I'd like us to put on our hats, or actually, sorry, our lab coats and our safety goggles, and take on the user persona of a scientist in the lab, right? So this scientist, we're all scientists in this lab. We have probably about 5 or 6 different instruments, right? Not all of the same instrument class, so each one has its own instrument class, right? Some of the data that is generated goes to the cloud, some of it goes to the local computer, and some of it goes to a file share, okay? So that's trying to set the imagination of where we're at. And our job is to go through our normal daily work, right? All right. So what does this mean? Well, so while we're doing this, right, you have to be able to access all this data, right? We'll say that at least half of those 6 instruments all have a vendor proprietary software data format, right? So it becomes difficult to get your data out of the system. Some of them might have a database that you can't even access to get your data out, right? So it becomes very difficult for us to aggregate our data across these different data sources, as well as all of these different data formats. And I'm sure, you know, for those of us that are actually, you know, scientists in the lab, I'm sure this will resonate with you a lot, as well as those of you that develop software to help us scientists in the lab, right? You've probably heard this before. Well, unfortunately, all of this that I just said, you would think that decades ago this had been solved, right? Well, just as we've heard today, that's not the case. So, during this whole process, right, we're going to start our experiment in our ELN, or we're going to get samples from our LIMS management system, right? We're going to have to take that information, we're going to have to go into the lab, plan out our experiment, we're going to have to collect weights, pHs to make our mobile phases, to make our diluents, and all this kind of stuff, right? Then we're going to have to manually transport all of this data into our electronic notebook or back into our LIMS system, right? So obviously that's a huge pain point, right? That becomes a problem because we're doing a lot of manual transcriptions. Guess what? Every manual transcription, for those of you in a regulatory environment, what does that mean? That means you have to do some sort of second person or second scientist review, right? Because you could always have fat-fingered a number. So all along this process, right? And then we have to go and get our instrument, collect our data on the instrument. Then we have to go and aggregate all that instrument data together, and we have to put it back into that LIMS or the ELN, right? Because that's where our results go, right? Again, we have to do all of that manual aggregation, and sometimes it's not available, right? And then if we want to go and start doing AI, predictive modeling, all these other fun, cool things, right? We have to go and even do it even more, right? It becomes more and more of a problem, right? So in this whole process, there's about 5 general pain points that we end up having to try to solve in order to actually get business value realization at the end, right? So you might be wondering, Chris, why are you transporting me back into a scientist lab, right? We're here at an Allotrope Foundation. We're talking about data standards and all of this stuff, right? Well, I'll tell you why. That's because I see this as part of this process, right? So if we start taking and we start looking at a conceptual architecture, now this is kind of simplified. I did try to make it simplified so it wasn't going to be take you to an eye doctor and have you try to squint and see everything. And yes, I did fall into the same trap as I just called someone out this morning on, right? And that is that there is not an arrow that goes from the end back to the beginning. But we have to find a way to be able to take some of this data, move it from one place to another, make it easier to aggregate the data, right? And we feel at Merck that one of those ways is through the Allotrope Simple Model data format, right? So if we take the 5 different vendors that have chromatography instrumentation, for an example, and we can convert that all into a standardized data format, it makes it easier to build our consumption pipelines, right? We then land it all in one central repository. That's the collect the AWS ASMs, right, in our Amazon S3 bucket, right? And then we end up consuming them back through an automated transfer process using Medcon, which I'll get into a little bit later, but just think of it as it's a Python connector that has the ability to also do complex secondary data calculations, because oftentimes our instrument softwares can't handle some of that complex nature, right? And us as being that scientist, what do? We copy data into Excel. We then do a whole bunch of macros, and then we copy the data out of Excel back into ELN or LIMS, et cetera, right? So if we had a way to automate that, again, we validate the automated process once. Now it's going to work 100 times. That's 100 different reviews that now we don't have to do for that one method, right? Now think about all the different methods, right? We were using 6 different instruments, right? So that's 6 times that we don't transfer the data, we don't aggregate the data. We also then don't have to have Vinny, my colleague in the lab, have to review my data, right? And go, Chris, you fat-fingered it again. What are you doing? And then we end up consuming it also, and that all has to happen obviously in a GXP environment. Right now our data lake is not GXP. There's still discussion on whether or not we should make our data lake GXP. But for now, our architecture is able to deal with it without it being that way. So then we take that instrument data. You'll also see a line in there from our experimental metadata that ends up having to go to our data lake, as well as something that I know wasn't talked about a lot, but I think someone started to talk about it earlier, and that's our process data. So our PA data, our PAT data, right? All of this has to be aggregated into our data lake so that then we can do structured data consumption, either in a lab scientist such as we are, or for our data scientist friends, right? And all of them have different kind of requirements. So why ASM? Well, I kind of hinted at it already, but it really helps us to be able to bridge the gap across the different vendors, right? Get access to our data where we normally can't. It also then gives us the ontologies, adds contextualization, right? And that context helps us to be able to more easily consume the data and aggregate it with other things. Also, you know, JSON is a pretty widely preferred format, so it also becomes pretty easy for things to consume it. And the one thing that I will say that besides just what Allotrope does from a standards perspective and allows us to, you know, take those 400 different instrument proprietary data formats, it also, Merck doesn't have IT or SMEs, right, to be able to go it alone and build these standards, right? We're not in the business of creating data standards. We're in the business of making drug products and helping our patients and our customers, right? So that's where we see this as a big community. We come together, we all agree on things, and then we can go and use those standards, and Allotrope can own the standards, and then we get to utilize them. So I do have to, so as part of this process, we have been experimenting with a new Agilent Open Lab Empower ASM Converter. So just as the safe harbor, it's down there at the very bottom of this slide that Tony ended up showing earlier. But obviously this is experimental, so please, this may or may not end up becoming a solution, but we were able to start to experiment and potentially use it before it was fully released, or if it gets fully released. But for part of our data, because some vendors are not as open to these open data formats and like to hold your data in their proprietary formats, we oftentimes, even though our first principle is to have native ASM generation from our instrument vendors, hint, hint, nudge, nudge, know what I mean? Say no more. Anyway, sorry, my Python joke. But when we don't, we also like to try to go to the SMEs or the vendors that might be SMEs in that area, which is why we were interested in the chromatography ASM converter that Agilent's been working on. So how do we put this all in, right? So great, we have these standards, right? Previously, prior to my joining Merck, they had an AI-DCS effort, so automated instrument data capture solutions to standardize the data, right? But one of the things that we were hearing from our scientists were, great, we have ASMs, what do we do with them, right? Without having those data consumption mechanisms, you don't realize any data or any business value. So we rebranded, and now we're automated data enablement, which I know Vinny might not like the name, but we help to aid the scientists in their automation of their laboratory, right? So as part of this, we had that MedCon thing. It's called Merck Extensible Data Connector just because it was built in-house. But it enables chromatography ASM data to be automated, automatically transferred into signals, right? As well as it allows for secondary calculations so that we can get away from using Excel or other types of secondary processing applications. And obviously, again, I can't stress it enough, but we've done some investigations, and about 45 minutes on average it takes to aggregate and transfer the data for a scientist. Double that for the review, right? So now you're talking just one analysis, an hour and a half. Multiply that by all the analyses, multiply that by all your scientists, and that's some real time savings, right? So our other consumption that we're going to highlight today is around the consumption of ASMs for data visualization, right? So in that conceptual architecture, we had MedCon doing the transfer of data to LIMS and ELN. What happens when we end up putting it into our data lake? So one mechanism, so the other consumption mechanism that we have is the ASM data ends up getting translated into a knowledge graph, right? Think AWS Neptune. It ends up going into a knowledge graph, right? We have the MDO is both the Allotrope ontologies as well as the Merck ontologies, right? So we can contextualize that data both with Allotrope ontologies as well as Merck when there are not Allotrope ontologies. And we end up creating a data product in our data lake, which is a knowledge graph. Well, that's great for the instrument data, but what do we do about the ELN data? Well, that data has to come in. Right now, we're bringing that in through a Redshift database, right? So that's our data product. And then the third thing that we see in there as a data product is something to do with the process data. What to do, we don't really know yet. We're working on that. But then the hope is that after we do solidify what that data product is, that we can combine all three of them, right? Because that's where we get the multiplicative power of doing the aggregation of all of the disparate different types of data together. And then what do we do with it? Well, oftentimes there's data visualizations we want to do, right? We want to understand so that we can in our lab, right? So going back to being a scientist, you have 5 methods to run and you need an HPLC. We should be able to go out into our lab and say, What systems are being utilized currently? What aren't? What do we normally run these methods on? We could also look at system suitability and look at what LC might be working and what's not currently, right? So we could be able to know which ones we could go use and which ones we can't. There are lots of softwares out there that can handle that for a vendor-specific instruments, right? But when we start thinking about beyond just chromatography, what if we also want to see what our plate readers are doing? But our plate readers and our chromatography and our cell counters, right? That's when you start having to break out of the silo of one vendor's software product. And then there's also things to be able to help, right? So review by exception, we keep getting heard of in the regulatory environment, right? Well, what if we monitor our assay? We can see it. It keeps getting plotted along as long as it stays within 3 sigma or 2 sigma, whatever our confidence intervals are, right? We don't review the data if it doesn't fall either way above or way below because we have it under control and we know what our system is doing, right? Same thing for impurity tracking or profiling, right? We can understand what our impurities are doing, and when they go up or down, then that's a time where we should step in and start doing something. And then something else that I don't think I've heard it talked an awful lot about, but we also have a lot of CRO data, right? So we have to be able to understand what's our CRO doing versus what we're doing, right? And to be able to compare those results. That's really kind of difficult right now, right? So we're also trying to build out data visualization dashboards that will help with that. All right, so this is going to be tricky. Hopefully this works. All right. I can barely see that on here. Nope, that was not the thing to have done. Can I make it bigger on here? Nope.
So you want to make this bigger?
Yeah, I want to make this bigger so that I can actually see it and talk while he's doing things.
Not good. So there we go.
Otherwise, I'm going to have to stand in front.
How's that?
Okay. I think it's okay. All right, is it playing? This is the problem of doing videos and demos, right? All right, so, yep, okay, there we go. Except I don't see, how do I get out of this? Let me just go.
Just take this and stand in front?
Yeah, maybe we'll do that. Is this on? Can you hear me? All right. All right, so here we are in Signals, right? So we have our table where we want to have a bunch of data that ends up being imported into Signals from Empower. All right, so he's going up here. It has a nice little external action as part of this table. It's actually called MedCon, so they actually renamed it, so it said MedCon. But you end up clicking on that external action. It ends up going out and calling the MedCon script, which ends up bringing this up, where you end up being able to select your Empower projects, so you can type them in. And then, obviously, anyone that's familiar with Empower, for a list of projects, you'll get a list of result sets, right? And it actually brings that back for you, right? So you don't actually have to type in or know what your result set is. You can simply select from the drop-down. Now again, if anyone's familiar with Empower, besides just a result set, you can also reprocess that result set multiple times and get different result sets, right? Or results. So you can select the results, and here I think he's actually choosing the samples. So within that result set, you can choose which sample or samples to include. And then you click the last button there, which was run calculations. So that's obviously if there's any of those secondary calculations that need to be run, it's going out and doing them as per that Python script that is 100% validated and controlled. So not everyone can go and edit them, right? So we have them within a GitHub repository. We lock them down, get them validated, and they only get enabled for people to use. And as you can see, it now has done all the calculations for any data that needs to fill the table that there wasn't the original primary results for, and then it populates your table for you. All right, so this one I was really hoping that the video would... No, next slide, please. All right, so this one I was really hoping that the video would play for and we could hear him because I'm not as familiar with the system utilization dashboard. But basically within Spotfire, you can go in here and there is a dashboard in there that was designed for empowered data visualization. You have the ability, right, so people could select what groups. So these are different analytical groups within the research labs. So here he's picking his group, which is SMART, small molecule AR&D, if you're really interested in what that acronym is for. And so now it ends up grabbing all of the instruments for that area, and it gives you a heat map of on which day, right, whether or not your samples were run average amount, which is a greenish color, if there was very little samples that were run, which is a purple color, or there is a max number of, right, so basically it's been used pretty much all day long or it's fully utilized, right? So this enables you to also start to do lab planning, right? So next time you end up going out to, your boss as being a scientist and you go, I need a new instrument, right? And your boss says, I don't know. Instrument one and the last one there looked like it wasn't utilized very much. How about you guys utilize those before I buy you? You can also look at it in a different way. So here you're looking at each instrument and you're looking at what types of runs or what methods, right? You're analyzing on there. Maybe actually this one is which users were using it. Again, you can still see, hey, there's quite a few instruments down here at the bottom that aren't very utilized, right? So maybe we should get full utilization or maybe 75% utilization before we go and buy a new one. Well, maybe this is the one that was actually showing users were using. But you can also see that you can look at multiple different things here, right? So you can look at column serial numbers, you can look at usernames, so you can understand what columns are run or what columns are on, right? We, of course, couldn't have them up here, but you can also look across your different work products, right, that we're analyzing for. So you'd be able to understand which work products were being used or which samples you're running on which. All right, so hopefully, as Vinny had said in the beginning, right, oftentimes in a lot of these presentations, we all talk about, hey, this would be great to do. Here's what we plan to do. This is what we want to do. This is actually us putting it into actual fruition and making your life easier now in the lab, right? So as I said, I'd bring you back so you can take off your lab coat, you can take off your goggles, make sure to throw your gloves away in the appropriate disposal place, and you can come back to being here in the harbor. With that, I'd like to thank you all for your attention.